Okay, so here we are. This is still in chapter 6, section 1. So we are continuing looking at normal distributions. And now we're going to consider the standard normal distribution. This is a normal distribution where the mean is exactly equal to 0 and the standard deviation, sigma, is equal to 1. And so in this sketch of the standard normal distribution, you can compare this with the one in the previous video. Instead of mu at the center, we have 0 because mu is equal to 0. And instead of saying mu plus 1 times sigma, mu plus 2 times sigma, and so on and so forth, since sigma is equal to 1 and the center is already at 0, we're just going to say 1 and 2 and so on and so forth. So this is what we mean by standard. All right, it is a normal distribution. It is a bell-shaped curve. It is symmetric. The area on the left half and the area on the right half are equal to one another. But what makes this standard is that we have centered it at 0 and we have set our standard deviation to be exactly 1 unit. So we basically made here the go-to, the standard normal distribution that we're going to be using every time we have a variable that is either normally distributed or approximately normally distributed, ditto, ditto. We will convert the x value to a z-score in order to use the standard normal distribution. So if a variable is normally distributed, or we can bend the rules and just assume that it's normally distributed, then it has a distribution curve that looks basically like this, except these values are pertinent to whatever data set that is. So its mean might be 59.3 and its standard deviation might be 26. And so these values might be horrible numbers in here. But what we're going to be doing is taking our data value, our x, convert x to a z-score in order to use the standard normal distribution. So that way we can use just one single distribution where all of the values are all worked out already and put together for us. And we don't have to reformulate the distribution every single time we use it. So here we're going to recall, how do we compute a z-score? Z is equal to x minus mu all divided by sigma. Or in other words, you take the value out of the distribution minus the mean of the distribution, okay, and then divide by the standard deviation of the distribution. And we're going to be using table E. It's page 779 through 80. Or, well, since it's in the appendix section, it's in A11 to A12. And that is what we're going to be looking at. We're going to be going through these exercises in the textbook. In just a minute, we'll go through one by one, but we'll illustrate how to use table E in order to look up areas underneath the standard normal distribution curve. And that will be in the next video.